Welcome everyone. This is this session 10 from the chapter of work, power and energy. The topic is collision. So here on this board I have written few bullet points which describes the collision in brief. So the first point is what is collision is the interaction between two or more bodies resulting in an exchange of energy and momentum. So this is an important definition. The first definition is that collision is the interaction between two or more bodies which results in an exchange of energy and momentum. Second important point, in collision, equal and opposite forces act on each colliding bodies. Now collisions are basically of two types. First one is the elastic collision and the inelastic collision. So in this session, I will be discussing about this elastic collision, and in the next session, I will be discussing about the inelastic collision. So in the elastic collision, there are two important points. This is the first one and this is the second one. The first point says that the total energy and the total linear momentum of the colliding particles are conserved. Second is the total kinetic energy before and after the collision also remains the same. So now I will be discussing about this elastic collision now, and now the elastic collisions can happen in one dimension and two dimensions. So elastic collisions can happen in one dimension and two dimensions. So I will be separately discussing about the elastic collision in one dimension, and then I will be discussing about the elastic collision in two dimension. So for this, for discussing this point, I will be making here a small diagram. Let us say there are two bodies here which are lying on a horizontal surface. This is one body and this is the another body. Let us say the mass of this body is m1 and the mass of this body is m2. Now let us consider that these two bodies are moving in one dimension, and their velocity is their respective velocity is, say it is u1, and let us say the velocity of this body m2 is u2. u1 is the velocity of the body m1 and u2 is the velocity of the body m2. So now they are moving in one dimension in the direction of this arrow. Now let us say these two bodies collide, and after the collision, this is the body of mass m1 and this is the body of mass m2. Let us say after the collision, the velocity of this mass m1 is v1 and the velocity of this mass m2 is v2. So here, as per the definition of the elastic collision, the first point was that the total energy and the total linear momentum is conserved, and second point was that is the total kinetic energy before and after the collision remains the same. So since the linear momentum is conserved, therefore we can write that linear momentum before collision is equal to the linear momentum after collision. So based on this concept, we can write that the initial momentum before collision is equal to m1 u1 plus m2 u2, and the final the total linear momentum after the collision will be equal to m1 v1 plus m2 v2. Now I think everybody must be knowing what momentum is. Momentum is the product of mass and velocity. So the momentum of this body, that is m1, is equal to m1 u1, and the momentum of this body, that is m2, is equal to m2 u2. So the total linear momentum before the collision is equal to m1 u1 plus m2 u2, and after the collision, the velocity of this this body of mass m1 is v1, and the velocity of this mass m2 is v2. So the linear momentum after the collision will be equal to m1 v1 plus m2 v2. This is the total linear momentum. You can write it here. The total linear momentum before collision is equal to the total linear momentum after the collision. So this is the first equation which we have got. Now this in the case of elastic collision, the total kinetic energy also remains the same. That is, the total kinetic energy before the collision is equal to the total kinetic energy after the collision. So it implies that the kinetic energy of this body is equal to half m1 u1 square plus half the kinetic energy of this body will be equal to half m2 m2 u2 square, and this is equal to half m1 v1 square plus half m2 v2 square. So this is the second equation which I have got. Okay. So from these two equations, I will be deriving certain relationships, and so for that purpose, I'm just rubbing this part of this board in order to continue deriving the relation from these two equations. So from here, if you just see from the equation 2, that is, this 1 by 2 will get cancelled out. So I will be getting two equations now, that is m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2, and this is m1 u1 square plus m2 u2 square, and this is equal to m1 v1 square plus m1 v1 square plus m2 v2 square. So I will be now solving this equation, and so here what I will be doing here, that is this term, that is m1 v1 square, will be taken on the left hand side. So I will be taking it as m1 u1 square minus v1 square, and this m2 will be taken on the right side of this equation. So this is m2 will be common, so we can write v2 square minus u2 square. Okay. So from here, m1, this will be u1 minus v1, u1 plus v1. Now I have used a formula, that is a square minus b square is equal to a minus b into a plus b. Okay. So using this formula, this u1 square minus v1 square has been broken down into into this u1 minus v1 and u1 plus v1. Now similarly, this can be written as m2 v2 minus u2 v2 plus u2. Okay. Now from this equation 1, from equation number 1, m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Now u1 and u2 are the initial velocity, that is the velocity of these two bodies before collision, and v1 and v2 are the velocities after the collision. So here what I will be doing is I will be taking this term on the left hand side. So I will be getting m1 u1 minus v1 is equal to m2 v2 minus u2. Okay, so this is the from this equation 1 I have got this relation. So what I can do here from this, let us say this is the equation number 3, and let us say this is the equation number 4. So from 3 and 4, from equation number 3 and 4, what I can do is now that here you can see that this m1 u1 minus v1, m1 u1 minus v1 is equal to m2 v2 minus u2. So I can just substitute this value, that is this value, from equation number 4 in equation number 3. So substituting the value of this m1 u1 minus v1 from equation number 4 in equation number 3, we get, if I put this value as m2 bracket mein v2 minus u2, so I will be getting here as m2 v2 minus u2, and this is u1 plus v1, and this is equal to m2 v2 minus u2 into, I'm just writing it here, into v2 plus u2. So this is the relation which we have got with the help of this equation number 3 and 4. So from here you can see that this m2 v2 minus u2 and this m2 v2 minus u2 can be cancelled out. So what I will be getting here is, it implies that u1 plus v1 is equal to v2 plus u2. Okay, so it implies that u1 minus u2 is equal to v2 minus v1. Now this is a very, very important relation. I will just try to explain what is this. This is the body of mass m1 and this is the body of mass m2, and this body was moving with a velocity u1 before collision, and this body was moving with a velocity u2 before collision in the direction indicated by the arrow. This is before the collision, and after the collision it is v1, the velocity of, this is m2, and this is v1 is the velocity of this body of mass m1, and v2 is the velocity of the body of mass m2 after the collision. This is after the collision. and this is before the collision. Okay? So now here you have to understand one thing. When what is the condition when these two bodies will collide? If they are moving in one dimension, these two bodies will collide only when the velocity of this body, that is mass m1, is more than the velocity of this body of mass m2. Because then only this body will collide with this body, that is m1 will collide with m2 only when the velocity of this body of mass m1 is greater than the velocity of the body of mass m2. That is, what is this? So u1 minus u2 is what? This is the relative velocity of approach. So u1 minus u2 becomes the relative velocity of approach of these two bodies. That is, this is the relative velocity of approach before the collision. And what is v2 minus v1? See, if the velocity of this body of mass m2 is more than the velocity of this body of mass m2, that is, if v2 is greater than v1, then what will happen? Then the two bodies will go apart. That is, if the velocity of m2 is more than the velocity of m1, then what will happen? The separation between these two bodies will keep on increasing. That the separation between these two bodies will increase. So here you can see from this relation we see that u1 minus u2 is equal to v2 minus v1. And now v2 minus v1 is we can call this as the relative velocity of separation. v2 minus v1 is the relative velocity of separation if the velocity of m2 after collision is more than the velocity of m1 after collision. And if it is so, then these two bodies will means the separation between these two bodies will increase. So in other words, we can say that in the elastic collision in one dimension, the relative velocity of approach is equal to the relative velocity of separation. So so in this session, I have discussed about the elastic collision in one dimension. In the next session, I will be discussing about the elastic collision in two dimension. And so till then, have a nice day. Bye.